Hello everyone, this is Chen Lu. Today I'm going to talk about AI algorithms in autonomous vehicles, mostly focused on K-means clustering algorithm. Nowadays, autonomous vehicles becomes more and more popular. A lot of companies like Tesla, Waymo, Cruise, Aurora, they have played a lot of effort in autonomous vehicles. So how to make autonomous vehicle work? For an autonomous vehicle, it should at least have the ability like perception, localization, prediction, and decision making. So here I mostly focus on introducing the perception part. So what is perception? Perception could help the cars to see the world around itself, as well as it could recognize and clarify the things that it sees. For example, for perception, it should have the ability to clarify the traffic lights, pedestrian road signs, walking ways, parking spot lanes, and so on. Also, it should have the ability to know exactly what the distance between each object. Autonomous vehicles usually requires a lot of sensors for achieving the perception. The mostly common used sensors are camera, LiDAR, and radar. Cameras could provide vision to the car, enabling multiple tasks like clarification, segmentation, and localization. The picture on the right is a view from the Tesla's Model S camera. Camera mostly works pretty well in perception, however, it has its own limitations, especially like when in the extremely weather condition like raining, fog. The data from camera could be noisy and discrepancy. Besides, camera can mostly won't work very well during the nighttime. So in order to solve this problem, we might need camera to working together with some other sensors, which is less light dependent and also like could have the ability to measure the distance. LiDAR is a sensor which could measure the distance of the objects. Since it has the ability to gain the depth of an image, so if we combine the LiDAR with cameras, it could create a 3D perception of what is going on around the car. The pictures on the left top shows like how objects was detected with LiDAR. Yeah, just like some other sensors, LiDAR has its own limitations. LiDAR isn't work well at extremely conditions like rain or fog. Radar is another sensor which could measure the distance of the objects. Unlike LiDAR, radar is more effective because it was using radio wave instead of laser, so it could works for any condition. Yeah, for sure. Radar has its own limitations as well. Like for radar, it's a noisy sensor. So compared with LiDAR, the signals received from radar is more noisy. So the pictures on the right side compare the difference between LiDAR and radar. So if we are using radar, we might need some other filter algorithm to filter the signal and interpret the signals. Okay, now we know we can achieve perception with the sensors we mentioned above. And let's assume we have the data from the sensors we mentioned above. How could we do data cluster? For example, assume we have the data from the sensor like in this plot. How could we know which cluster could represent the dimension of a car and which cluster could represent the dimension of a cyclist? So here I'm going to introduce K-means clustering algorithm. Okay, so what is K-means clustering? K-means clustering is an unsupervised learning. It will divide the object into different clusters based on the similarities. In other words, data like is very similar to each other will be grouped together, and data that is largely different from each other will be grouped separately. So how could we decide how many clusters it will have? So in K-means clustering, the objects are divided into the clusters based on the K value. For example, if K equals to 2, the objects are divided into two clusters, C1 and C2, which is as shown on the right side. Okay, so here I'm going to explain how K-means clustering algorithm works. So let's say we have n point as our input and we want to divide our dataset into k clusters. So firstly, we want to choose k random point as cluster center, which we also call the cluster center as centroid. And after that, we want to go through all of the points and assign each point to the closest cluster. The method we find the closest cluster is by calculate the distance between points to each centroid and find the minimum one. Step 3, after we find the cluster, we want to identify new centroid by taking the average of the assigned points in its own cluster. And after that, we will repeat step 2 and step 3 until the cluster becomes stable, which in other words, the centroid won't changing. So that is how we finish our finding and clustering and finish clustering. Here is a flowchart of the k-means clustering algorithm. Firstly, find out the optimized k-value, which we will discuss this method later. And then measure the distance, grouping the data based on the minimum distance, and then reposition the centroid. Repeat the distance part until the reposition part until our algorithm converges and the clustering become stable. So the plot below is an example of how k-means clustering works. So assume we want to divide the data into two clusters. Firstly, we will randomly choose two centroids. So here we choose this point and this point. And then we split the data into two clusters based on the distance between point to clustering. So the points around this side are all closer to this centroid compared to this centroid. So this area is one cluster and this area is another cluster. After we go through all of the points and find its corresponding cluster, we'll reposition our centroid. So for this cluster, we calculate the average of the points. So we find the new centroids for the blue one, for the blue cluster, new centroid is here. And also the same way, we calculate the average point for the red cluster, and we find a new red cluster with centroid here. And with a new centroid, we will reclassify the cluster. So same as before, we go through all of the points and find the closest centroid. So as we can see here, the data on this side are more close to the blue centroid. So this section is the blue cluster. And the data below are more close to the red centroid. So this part is for red cluster. And after that, same as step 2, we will reposition our centroid. So we have the red cluster here, and we calculate the average of the points for this cluster. So we find a new centroid, red centroid here. Same as the blue one, we calculate the average of the blue point and find the new centroid blue cluster here. And after we find the new centroid, we will reclassify the cluster. So still based on like the distance. So we find this section is the blue cluster and this section belong to the red cluster. And then again, we will go through, we reposition the centroid again. And for the step 6, we can say like the centroid is same as the step 5, which means we are done for the clustering process. The cluster is stable now, and we find the best clustering for this data. And that is how the k-means clustering algorithm works. Okay, now we know how the k-means clustering algorithm works. But another question is, what is the optimized value for the clusters? How should we choose the value of k? So one of the common method for find the value of k is named album method. Album method is using the within sum of square as a measure to find the optimized number of clusters. Within sum of the square is calculated by the sum of the square distance between each member of the cluster and its centroid, which is shown as the function below. We'll calculate WSS values with k as different value, and then we'll draw a curve between WSS and the number of clusters. So within that plot, usually they will have a turning point where after the turning point, the WSS value would change very gradually. So we will call that turning point as elbow point, and the k at the elbow point is the optimized k value. And also the value at the turning elbow point is the optimized number of the cluster based on the elbow method. This page shows a reference source for this presentation. To sum up, today I have briefly described how autonomous vehicle works, as well as what's the most common sensor used for perception for autonomous vehicle. And also after we gain the data from the sensors, how could we do data cluster? So therefore we further introduce k-means clustering algorithm, which is commonly used for data clustering. And also we have described a method to find out the optimized value for the k-means clustering algorithm. That is for today's presentation. Thank you for watching.